In this video, we're going to talk about how do we make histograms by hand and using Excel. So we know histogram is used to describe numerical variables. So if you have a numerical variable, you wonder, what kind of information, general information you can get. You can make a histogram and it will provide with us a lot of information. Okay. So for example, here we'll look at one numerical variable. It's exam score. So suppose those are scores from students from a small class. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 individual scores. So in order to make a histogram, you have to make a frequency table. So for one side of the frequency table, it will be classes. In software, it's also called bins. And the other side will be frequency. So how do we define classes? The classes have to be continuous. We need to include all the number that's possible within your data range. And also the different classes have to have the same widths. And the histogram, most of the time, it requires you to have 7 or more classes. So how do we set the widths of the class? So the width, you can roughly estimate it by the range of your data and the number of classes you want to make. So for example here, we want to make 7 different classes. So we're going to use the range of our data. So 93 subtract 21, and then for that result range, we divide by number of classes. So in that case, will be 72 divided by 7. So our width is going to be approximately equal to 10. Okay. So keep that in mind. We're going to define our first class as from 20 to 30. Okay. So a bracket on the left hand side and a parenthesis on the right hand side. What it means is this class will include all the values that's between 20 and 30, but including 20, not including 30. So left inclusive. And so we can define all the rest of the classes the same way. So the class has to be the same width. So make sure they have the same width. So from 30 to 40, including 30. From 40 to 50, including 40. 50 to 60. 60 to 70. Then 70 to 80, 80 to 90, and 90 to 100. So, check again. The class is defined continuously. So all the numbers will fall into one of the class here. And the class covers the whole data range from 21 to 93. And the classes have exact the same widths. Okay. So after classes are defined, we just need to count the frequency. So how many scores are in each of the classes? Between the score of 20 and 30, we only have one score, 21. So the count will be 1, frequency equal to 1. Between 30 and 40, we have no score within that range. So the frequency will equal to 0. 40 to 50, also 0. 50 to 60, another 0. Between 60 to 70, we have one score, 61, so the frequency will be just 1. Between 70 and 80, we have 73, 76, 77, so the frequency is 3. From 80 to 90, the frequency is 1, 2, 3 as well. From 90 to 100, we have 2 students with that score. And to verify, you can just add all the frequencies up, 1, plus 1, plus 3, plus 3, plus 2. It should add up to total individuals in your sample data. So we have 10 individuals. So once you draw your frequency table, then we can start to make our histogram. The histogram has two axes. Okay, we're making a vertical histogram, so the x-axis will be the variable you're trying to describe. So will be the exam score, will be our x, and the y-axis will be the frequency. So both axes are numerical axes, so make sure they're marked appropriately. So for the score, you can mark your axes based on your class. So we can mark a 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay. For the y-axis, it's going to be the frequency in your frequency table. So the range will be from 0 to 3. So we're going to mark a 0, 1, 2, and 3. Okay. So now both axes are marked appropriately. So we're going to start to draw histogram. The histogram, draw histogram just like drawing bars for each class. So between the class 20 and 30, the frequency is 1. So we're going to draw a bar with a height of the appropriate, the corresponding frequency number, 1. And between the 30 and 40, we're going to draw a bar with height of the frequency of that class equal to 0. So it will be a baseline. 40 to 50, same thing. 50 to 60 is also 0. From 60 to 70, the bar height will equal to the frequency equal to 1. So from 60 to 70, we're going to draw a bar with height equal to 1. With 70 to 80, we're going to draw a bar with height equal to 3. So if you have a ruler, you can make the histogram look even better. Okay. From 80 to 90, the frequency is also 3. So the bar height equal to 3. And then from 90 to 100, the bar height is 2. So after you completed all the bars for each of the classes, then your histogram is finished. So to read the histogram, you can see, we can easily see that there one student scored between 20 and 30. We have one student scored 60 to 70. We have 3 students scored between 70 and 80. We have 3 students scored between 80 and 90, and you have 2 students scored between 90 and 100. So that gives us, a lot of details about all the score distributions. So other than all those details, we have a few features we want to look at from the histogram as well. So one thing is mode. So mode will refer to the most frequent values in your data. So basically, you're going to look at the highest bars in your data in your histogram. So in this case, you can see these two bars are the same height. So the mode will be kind of the middle. We can use the middle value over here for the same height bars here represent the mode. So mode will be 80-ish, right? And then after you find the mode, we can describe the shape of the histogram. For shape, we have two, either symmetric or skewed. Okay, so what we do will be, we're gonna draw two tails for both sides of the mode. Okay, so if the two tails on both sides of the mode are same length, we call it symmetric. If one side's tail is longer than the other side, that will be a skewed distribution. So in this case, we can see the tail on the left, it's longer than the tail on the right. So this shape, we call it left skewed. Okay. We can also call it negatively skewed, because the longer tail is on the small number side, so that's negatively skewed. On the other hand, if the tail on the right hand side is longer, they will be right skewed or positively skewed. So basically, just look at if the longer tail is on the small number side or big number side for the skewness. So this data will be left skewed or negatively skewed shape. Next thing we look at is the center. Center is kind of a rough estimation of the middle point. So, basically move your line on x-axis, and you're going to stop when that line separates the number of individuals, equally on both ends. But most of the time it's roughly estimated. It doesn't have to be that accurate. So in this case, center is also around 80-ish, right? And then spread. You can see the score ranges from 20 to 100. So you can just say the spread is between 20 to 100, right? And the last thing, very important though, outliers. Outliers are very important in statistics. I refer to one or a few data points that's extremely different from the majority of the data values. So in this case, that one student score is very different compared to the other values. So we call that as outlier. So this is how we manually do a histogram and how do we read from histogram. So now let's look at how do we use Excel to make a histogram. So first, make sure you're using the same Excel version. I'm using the 2016 version. So you can go to your file, click on account, and here it'll give you Excel version. Okay. So to make a histogram, you need to highlight your data first. So basically, you can choose the data range just like what we did earlier in the previous videos. You'll highlight the whole data range by clicking the first and last values and holding the Shift key. Okay. Or, alternative way for you, the easier way to do is just highlight the whole column. Excel will treat all the empty cells as, and they're just going to discard the empty cells because it doesn't contain any values. Okay. So in this case, we're going to choose the data by just simply click on the whole column, the A column, and then we're going to do a histogram. So we're going to go insert and then recommended chart, and then choose all chart, and then you browse through all the different chart, and we're going to pick histogram and click OK. So this is the histogram of our data over here. So if you click on you can make some modifications on the chart by simply click on the title. So we can change this into histogram for leaf length. So I forgot to mention, this is basically the same data as what we did earlier for the pie chart and bar chart. So we have, student will collect some leaves and they're going to measure the length of the leaf. So we have 170 different leaves for this data set. Okay. So we can do additional modification on the chart. You click on the chart and then click on this plus sign on the right for the chart elements. So here, data labels, if you check data labels, then the bar height for each bar in the classes is marked for you. Okay. So now we know, in histogram, the number of bins or classes will make the histogram look a little different. But for large enough data, it doesn't really affect much. The difference will be very minimal. So for example, in Excel, we can manually select, how you want to define your classes. So for example, just click on the, the class area under the histogram, you can see it's selected, all the marks, and then right click, and then you go to format axes. So then here it's going to show you, the number of bins and bin widths. So right now the chart is made by automatic. So it's automatically set the number of bins for you. Most of the time, automatic is good. But if you do want to modify, you can modify by number of bins. Here by automatic is 9. If you want to change into 12, this is what it looks like. Okay. Or you can modify by bit width. So here I give you 20.5. Maybe you can change into, 19. So this is what it looks like. Okay. But you can see the overall look of the histogram is not changed by much. Okay. And what you can read from the histogram, is very similar to the hand drawing part histogram I did earlier. So you can see out of the 170 leaves, there are 14 leaves, length between 7 and 26 centimeters, 26 leaf between 26 and 45 centimeters, and so on. Okay. So we still focus on the 5 features when you read the histogram or the overall, trend. So first, look at the mode. So what is the mode? Mode here will be this bar. It has the most frequent number of leaves, right? So in terms of class, between 64 to 83. So 64 to 83. So that's where the most of the leaf will fall in when you define the class this way. Okay. Then we're gonna look at what's the shape of the histogram or the shape of the data. So look at their mode is right here. You draw one tail to left hand side, another tail on the right hand side. You can see that the tail on the right hand side is longer than the tail on the left hand side, right? So it's on a big number side. So this will be a positively skewed or right skewed. Okay, so that's the shape. And then we can estimate the center of the data. So basically, what's the middle value of all the leaf lengths? So, you can roughly see it's over here, also between 64 to 83. Okay. And spread. So you want to see what kind of leaf lengths, values do we have. So for this sample data, the leaf length between 7 centimeters all the way to 254 centimeters. Basically the whole range of the leaf values. And then lastly, we look at, hey, do we have extreme data points, outliers? So here you can see these 3 leaves on the very top. They are very different compared to the rest of the leaf lengths, right? So they are very, very, very long compared to the rest. So these 3 leaves could be outliers for the data set. All right, so this is how we make histogram by hand and using Excel. Thank you.